Hello and welcome to this little video where we're going to be talking about percentage yield. In this video we're going to talk about what the theoretical yield of a reaction is and what the actual yield of the reaction is. We're also going to talk about how we calculate the percentage yield and also look at why the yield isn't always 100%. So on to the first point, what is theoretical yield and actual yield? So let's look at an example. Let's take the reaction of burning methane. Okay, so we've got CH4 and we're going to burn it in some oxygen, and that reaction will produce carbon dioxide and water. Now, the theoretical yield of this reaction is something that you can calculate. So, for example, if I was to have 16 grams of methane, I can calculate what my theoretical yield of water is. And I'll do that in just a moment. The actual yield is normally what you're given in a question. So it will say, well, 10 grams of water is produced. So in seriousness, what is the difference between theoretical yield and actual yield? It's kind of in the name. The theoretical yield is something that you can calculate, and in theory, this is what you should get when you burn 16 grams of methane. The actual yield is, well, what you actually get. So when you do it, what is the mass of water that's produced at the end? Okay, so let's talk about how we actually calculate these. So there's no calculating when it comes to the actual yield. You'll be given that in a question, or you'll be told how much it is in a bit of a blurb. The theoretical yield is something you would need to calculate. So how do we do that? Well, we do that by using our reacting masses. So if we remember back to how we do reacting masses, we draw a little bit of a framework. Okay, we draw an arrow down to the side, we draw an arrow across, and we draw an arrow upwards. Okay, we can then write down, okay, down the side we've got our mass, we've got our moles, and then down the bottom here, okay, we've got our ratios. We should also hopefully remember that when we go downwards, okay, we divide, and when we go up, we multiply. Okay, so let's go through this example. The one thing that I've been told is that I've got 16 grams of methane. So here I've got to do my masses. So this is the mass that's in the question. Okay, what I need to write down is the actual mass of methane. Okay, the mass of methane, just to remind you, okay, carbon is 12, and then we've got 4 hydrogens, so that's 4 times 1, okay, which equals 16. So therefore we have 16. We're going downwards, okay, so we divide these together, okay, which gives us our moles, which is 1. We then move across in our ratios, and we look at our ratios. We've got a 1 here and a 2 here, so our ratio is 1 to 2. So if I've got 1 over this side, I'm going to have 2 over this side. I write down my mass of water, okay, which, to remind everybody, is 1 times 2, because that's my hydrogens, and then I've got 16, okay, which is my oxygen, which in total equals 18. So I can write my 18 here. I'm going up. So I multiply these two numbers together, I get 36 grams. So in this particular question, okay, my theoretical yield of water is 36 grams. Okay, this here is my theoretical yield. Okay, so why is this useful? Okay, well, now that I know what the theoretical yield is, if I did the actual experiment and was able to measure the mass of water produced, I could actually find out what the percentage yield of this reaction is, which is a really useful thing for chemists. You know what the percentage yield is? You know sort of like how much or how good a reaction this is. Really important with industrial processes, because as an industrial chemist, you want to have the reactions that have the highest percentage yield, because it's just more efficient, tends to be better for cost, and when you're trying to work out the economy of a business, it tends to be preferable. Okay, so let's use this question as an example. Let's say in the question, okay, or whatever it might be, it tells you that it produces 18 grams of water. So 18 grams of water was actually made. Okay, so using this bit of information, we can work out the percentage yield. So how do we go about finding the percentage yield? So the percentage yield equals the actual yield divided by the theoretical yield multiplied by 100. Okay, just a simple percentage calculation experiment. So in this particular question here, okay, what we're going to have is we're going to have the percentage yield equaling our actual yield, which is 18, divided by our theoretical yield, which is 36, multiplied by 100, which gives us 50%. Okay, so what we've done here is we've worked out the theoretical yield. Okay, we get told what the actual yield is, and then we use this equation down here, this one here, to work out the percentage yield. This is the important equation that you need to remember. Percentage yield equals actual yield divided by theoretical yield multiplied by 100. So, as if by magic, let's look at an actual question of this. So here's an example. Water can be hydrolyzed into hydrogen and water by the equation 2H2O goes to 2H2 plus O2. Okay, first part of the question, calculate the theoretical yield of hydrogen when 36 grams of water is hydrolyzed. And then the second part is, in the reaction in part A, the actual yield is 3.3 grams. Okay, what is the percentage yield? Really standard question on percentage yield. So what I'd like you to do, have a go. So pause the video, see how you do, and we'll talk about it afterwards. Let's have a little look at this. So this is my equation. I'm not going to write out the equation for a second time, just to save a little bit of time, but I can write out my little bit of framework. So I'm going to have my MR, or my mass, my MR, okay, and then my moles, okay, and then I'm going to have my ratios down the bottom, okay, going across to my hydrogen and then going back up. Okay, so I've got my ratios, M. Okay, the better you get at these calculations, the less of this structure you'll require. Okay, but here we go. So our mass of water is 36. Okay, the MR of water, okay, which we can work out as 1 times 2 plus 16, okay, which is 18. We're going downwards, so remember we divide. So therefore this is going to be a 2. I then look at my ratios, which is big numbers in front of things. So I've got 2 to 2, so that means it's a 1 to 1 ratio. We have 2 moles of hydrogen being made. Now, the one thing I've got to be careful of here is I've got H2. Okay, so that's 2 times 1, which means that my mass is 2 here. Okay, we're going upwards, so therefore we multiply together. So therefore my mass at the end is going to be 4 grams. Okay, so my theoretical yield, okay, of hydrogen here is going to be 4 grams of hydrogen. Okay, part B, in the reaction in A, the actual yield is 3.3 grams. What is the percentage yield? So this is where I use that calculation of percentage yield equaling the actual yield divided by the theoretical multiplied by 100. So in this case, my percentage yield is going to be 3.3 because that's what's given to me in the question, just here, divided by 4, which is my answer to the previous question, multiplied by 100. Okay? And that gives you the answer of 82.5%. So therefore, okay, we can say that the percentage yield of this reaction is 82.5%. So there's an example question. We've got one last thing to cover. So why is the yield not always 100% as calculated here? So let's get around to answering this question. Why is the yield not always 100%? So there are 3 main reasons, okay, as to why this is. The first is that the reaction doesn't actually complete. Now, this could be because we haven't left it long enough. So for instance, if we were hydrolyzing water, we may not hydrolyze all of the water because we just didn't leave it long enough. It's as simple as that. The other thing could be that it's a reversible reaction, and well, when you've got a reversible reaction, it's very difficult to get 100% yield. So that's the first one, that the reaction doesn't actually complete. The second is that for whatever reason, some of the product is lost. So what this could mean is, let's say, for example, we're hydrolyzing water. You would do this experiment in a closed system, but actually there's some issue with the equipment, which means that some of the gas being produced escapes. So some of the product is just getting lost. Now, if you're losing some of that product, then, well, you're not going to be able to actually obtain it. So this tends to be more of an issue when it's a gas, because you have gases escaping, but it could also be, let's say you're doing a reaction with a liquid, and when you're transferring that liquid from one beaker to another, some of that liquid stays on the sides of the beaker. So therefore, you're not getting all of your product across. The third and final reason is what we call unwanted side reactions. So if we have an industrial process that's happening at high temperatures, high pressures, those conditions could just mean that other reactions can take place. So whilst we're looking at a specific reaction that we want to happen because of the conditions in which the experiment are being done, other reactions are going to be happening that are going to be using up our reactants and turning them into products that we don't want. And that's just sort of part and parcel of doing chemistry on a larger scale. So when we're looking at trying to identify what reactions we want to use, these sort of three things as things that we will look at. We'll also look at the percentage yield. So ideally, you'd want a reaction that has a really high percentage yield, doesn't produce many unwanted side reaction, and we can actually do it in a way where we can make the reaction complete and not lose some of the product. And these are sort of all questions that industrial chemists will be asking themselves when they're constructing certain systems for whatever chemical reaction it might be that they're doing. So, just in summary of what we've done in this video, we've talked about what the theoretical and actual yield are. We've talked about how you calculate the percentage yield when you're provided with the actual yield. You'll always be given the actual yield, or you'll do an experiment where you'll find out, you'll make it and you'll actually record the yield yourself. And we've also talked about the reasons as to why the yield isn't always 100%. So thank you very much for watching this video. In the next video in this little series, we'll be looking at atom economy. But hopefully this is a little extension on the mole stuff that we've done so far. So, as always, thank you very much for watching, and I'll catch you in the next video.